So you see, if I use my data, okay, from the source that I have, the productivity index should be just around 3.44. Okay, it's far from the actual productivity index I get from well test, which is 14.3. So yeah, of course, dealing with subsurface issue, we deal with uncertainty, okay? And in this case, we have uncertainty, of course, in permeability. So that's why you need to correlate the permeability from well log with permeability from pressure build up, for example, and permeability derived from the well performance, like in this equation, like in this case, I mean. So in this case, I assume that the uncertainty belongs to the permeability. So let's adjust the permeability. Let's say the permeability is 250, and I changed the vertical permeability to be 25, still maintaining the 10%. So productivity index increased slightly. Okay, so I also can assume that we have actually uncertainty in the real open interval. Of course, by design, you know exactly that you want to perforate, let's say, 10 feet. But in reality, you cannot be sure how long actually the perforated interval actually resulted. Okay, most of the time, the hole will be bigger and bigger, maybe because of corrosion, maybe because of erosion, maybe because of poor integrity. So yeah, we can, generally speaking, we can guess that the open interval must be bigger than 10. Okay, so let's see, let's adjust. Let's see if the open interval 15. Now productivity index improves quite significantly. Okay, and let's see if it is 20. Now you get 7.7. Interesting, right? So, so it's like that. Okay, yeah, it's a challenge with well modeling basically. Yeah, because maybe you also, in the history of the well, you have acidizing, stimulation, you have water flood, so the permeability will change. Okay, 300, let's say. So skin factor, I mean the vertical permeability, 30, 10% of the horizontal permeability. Okay, and let's see if the open interval is 30. Now you get 13. Okay, so now we are very close to the, to the real productivity index. Okay, of course, you can also adjust like drainage area if you want. For example, it is 200, but you see, it's not significant. The change is not significant. Okay, it is, it's only 100 meter, but I don't think it's the correct number. So you can also change to 150 if you want, but I think the 250 is a good number. Okay, and yeah, maybe 200. Okay, for argument's sake. Okay, 200. You can also change to rectangular if you want, but of course there will be more issues, wedge shape, okay, and go back to circular to make it simple. Okay, so yeah, 310, 31. Okay, we are closer and closer to the real value. So what if we also assume there will be uncertainty in the perforation diameter, for example? Okay, let's check 0.39. Okay, you see the change is not significant. 0.4, right? Shot penetration, for example, 4 feet. You see 5 feet. Okay, 6 feet, 7 feet. You see, no change, no significant change. So you see that if you want to get the same number, 14.3, which you get from well test, yeah, we need to adjust the permeability in this case. So let's see 32. Okay, so let's see we can take this 14. Okay, and you can also click save. So you see now the productivity index is very close with the actual performance I get from well test data. Okay, so the absolute open flow 7,000. So with the same method, okay, I want to construct IPR, okay, for the new reservoir.